All right, going over the exam review for the midpoint of Algebra 1. We're working through some equations, some graphs. In my class, this is going to count as a culminating assessment grade, so make sure you get it turned in. Here we go. This first one, honestly, if you can't solve this first one, you're in a bad spot, all right? We're going to want to add 1 to both sides. We're going to want to divide by 3. We have done this process, I'm not even exaggerating, 300 times in the last 6 months, okay? Hopefully, number 1, you feel pretty good with x equals 3, all right? You gotta be able to solve for x. If you get to part B algebra and you're struggling with this, it's gonna be a long semester, okay? If this is a struggle, you gotta work hard, you gotta study tonight, you gotta look at this, you gotta do some old questions, you gotta do something. Question 2 has parentheses. PEMDAS reminds us that parentheses need to come first. And I'm going to go ahead and distribute. A lot of times when it comes to distributing, kids mess up the negatives. So when I see this first question here and I see the -2, a lot of kids do this and they mess up because they put that plus there and they do 2 times 1. And this is going to be incorrect. We need to make sure it says -2x minus 2. So let's make sure this looks like a minus. That's hideous. Whatever. -2x minus 2. It's a -2 times a +1. Okay, it's got to be a -2. If you get that, the rest of this question, very easy. It's just like number 1. You've got to move 2 things. You've got to first use addition or subtraction. So we use addition. We get -2x equals 10. Then we need to use division. Divide by -2, divide by -2. I think we can do this in our head as well. -2, 10 divided by -2, -5. Easy peasy, we got it. Half of 10 is 5. No stress. Hopefully these first 2 are feeling pretty straightforward. Hopefully you already did these with your little chance to get a head start. Hopefully those answers making you feel a little confident. Now, these next 2 questions also aren't too bad. These are equations with variables on both sides. You can see that we have an x over here and an x over here. Whenever you have variables on both sides, it's time to move the variables on the right over to the left, make one pile. And so I'm going to move this pile over there. I'm going to think of it like a -1x. I'm going to add 1x to both sides. That'll be 15x minus 7 equals 23. And now we're right back in that very comfortable place. Look how repetitive this is. Add it, divide it. Add it, divide it. And what are we going to do here? We're going to add it. 15x equals 30. And we're going to divide it. Divide by 15. Divide by 15. Final answer for this question. Anybody got it? So 30 divided by 15 is going to be 2. If you did 30 minus 15, it would be 15, but the answer needs to be 2. It needs to be 2 for this question. Not a big deal if you accidentally put 15. If you put 15, my advice would be use Desmos, right? Type that in, 30 divided by 15, get it right. 5 times x, 5x. 5 times 3, 15. Should that be a positive 15 or negative 15? Negative. Hopefully you're following along, writing this down. The plan is I designed this so that you would get a free 100% as long as you participated in the review. So I hope you're writing this down. Up next, let's move these x's over to the side so we can get everything in one pile. Very repetitive. That's what we just did. Can't really see? Up on the board? Can't do much better. I got the lights on. I got it zoomed in. Now, same exact process. We're going to add 15 to both sides. I mean, super repetitive. Once you start to learn and really understand equations is when you realize they're all the same. right? The questions are all the same. So we've got 1x equals 26 because 11 plus 15 is 26. And we've talked about this a lot lately. What do we need to do with this 1? You could divide it, but you could also just kind of get rid of it, right? It's the same thing. Because if we divide by 1, what's going to happen? Nothing, right? I mean, 26 divided by 1 is still 26. So what we've been doing lately is just kind of realizing that you can just get rid of that 1, right? We just don't need it. 1x is the same thing as a plain old x, right? I'll be honest with you, it's kind of like amateur algebra. You have to divide by 1 because it's just kind of a waste of time. It doesn't really mean anything. Okay, these first 4 questions, I hope they weren't too bad, right? Maybe we made a couple goofs, but hopefully they weren't too bad. Last 2 questions on the front, I think that number 1 is, I think that this first question of these last 2, I think that this question is probably the hardest algebra solver that we have. Okay, I don't think it's that crazy, but I think it is probably the hardest algebra solver. So if you've been chilling and gotten all these right, make sure you got this one right. For this question, I see that we have a fraction, and that's always a big deal. And to be honest, we don't really like fractions, okay? So how can we get rid of that 2 in the bottom? So, right, using opposites. This 2 is a divide 2, so we use the opposite of multiply 2. Times 2, times 2, times 2. Times 2, I guess there's 4 2's. And some of these 2's are going to cross off. Does the first 2 cross off with anything? No, so that's going to be 2 times 4 makes 8x. Let me get my nice line down the equal sign here. Does the second 2 cross off with anything? Yes. So this one does cross off because it has that fraction. And so what should be our number for the second term?
1.
Exactly, just minus 1. What should be our number for the third term?
6x.
6x, perfect. And what about the fourth term? 24 positive, easy. At this point, we are exactly where we like to be. Fractions might be a little scary, but fractions are gone. Like, it literally took us 1 step and the fractions just disappeared, right? They're not as scary as you think. We're gonna do minus 6x minus 6x. We've got 2x minus 1 equals 24. Because of course 8 minus 6 is 2. And this is so comfortable. We're right where we want to be. I hope you're following along and not distracted by something. We're going to add 1 to both sides. 2x equals 25. And then we're going to divide by 2. And this is a little bit funky, right? Because 25 divided by 2, ew, right? Kind of gross. 25 divided by 2, fraction. 25 divided by 2 is just 25 divided by 2. Sometimes that happens. That's okay. We've done many questions where we got fraction answers. X equals, what's up? That is, it's possible to get the same answer different ways. What did you do?
I had did negative 3, like a swap stuff. Like when you would normally solve a question, it's like that, and I got the same thing. But I didn't know what.
Oh, I got you. So you did a subtract 3 over this side.
Uh-huh.
And then what'd you do with that 1? Did you do a plus 1/2?
Yeah.
And then you got 12.5, or you made it already?
No, I did, and then I don't remember, but
I got you.
Yeah, I just saw that as a normal question.
So as a math teacher, to me, the longer that the fractions stick around, like the longer that people get kind of scared. So for me, I just kill the fractions very first step, right? It's like fractions, it's on site. You guys know what I'm talking about? As soon as we see them, they're out of there. All right. You know what I'm talking about this season. So over here, this last question, you guys can tell I'm going a little crazy on exam review day. This last question, we're gonna -3 both sides. That's not too bad, pretty standard. -4x less than 16. Now I kind of skipped ahead pretty quick and didn't slow down. We have a less than for this question. Make sure you keep up as soon as you can, because I'm gonna check this off. We have a less than, and that less than is gonna give us a tiny bit of a difference, okay? There is a rule when it comes to inequalities, right?
Switch it when you divide by a negative.
Perfect. Flip the sign if you divide by a negative, right? That was exactly what you said was perfect. Remember, you're watching out for that last step. Divide by a negative, gotta flip the sign. So here we go. Divide by -4, divide by -4. Are we gonna flip?
Yeah.
Of course, right? The x, that's gonna make -4, and we're gonna flip this around, do my little corkscrew here. It was a less than, now it's a greater than. You can also see at the bottom here, we're gonna have to do a little bit of an inequality graph. This is definitely a skill you wanna kind of feel good about. In part B, you're gonna do some harder versions of these. So down here, -4, we're gonna start with a circle on the -4. Our first decision, is it gonna be an open circle or do we need to color it in?
It's an open circle. It's an open circle because there's no line.
Sheesh. Nice job, you guys. You guys are serious about that. Open circles are symbols without the equal sign. So here's my little chart. On the open circle side, we have these two. Closed circles have the equal sign. So they have that little line underneath them. We obviously need to stay open. The last question is, are we going left or are we going right?
Right.
We need to go to the right. You guys are rock stars at this, I guess. Nice job. Right. Remember, if that is your symbol, you can make a nice arrow out of it and it will tell you which direction to go. Okay, nice job. You guys were awesome at those inequalities. Let's flip it over. Let's keep it going. Here we're going to get into some graphing stuff, which you might be thinking, I'm actually better at graphing. Or you might be thinking, So let's see how this goes, all right? We need to get the M and the B, and the good news is y equals mx plus b, which is called slope-intercept form, makes this very easy, all right? The m is the number in front of x, and the b is the number after x. So we can just grab those numbers and just put them right here, -5/2 and -3 as my b value. When it comes to plotting these, there's basically 3 quick steps. Number 1 is to plot the b value. You always are going to start with b. Some teachers like to say begin with b because it's like a nice little rhyme, kind of. So I'm going to put my first spot right there. The second step is that we need to do rise over run. So when it comes to rising over run, we're going to go up the top number. And then I'm always going to look at that bottom number. Negative means left, positive means right. So I see -2, I'm going left 2. 1, 2, 3, 4, 5, 1, 2. Put my dot right here. And I'm going to do the same thing again. Step number 3, rise over run. 1, 2, 3, 4, 5, 1, 2. There's my dot. I always do the eyeball test, make sure it's in a nice straight line. I'm going to go for it. Nice straight line. Go for it. Nice straight line. That's the whole question right there. Get your mx plus b, get your m, get your b, plot it, good to go. Now, the next box is probably the box that, I might highlight more than any other box, okay? These are kind of the weirdo graphs, all right? Not to hurt any of your guys' feelings, but these graphs, oh, come on, Mr. Collier. These graphs are the Hoy-Vux graphs, And hoi vux is just supposed to help you remember that horizontal graphs are the y graphs and vertical graphs are the x graphs, right? Hoi connects the h to the y in your brain. So when we see a number like this, y equals 4, there's no x. It is a y only graph. Is that going to be horizontal or vertical? It's going to be horizontal in this direction, right? Hoi, horizontal. It's going to go side to side. That means that the bottom graph, which is a Vux graph, is going to be a vertical graph that goes up and down.
Oops.
We have y equals 4. Here is a 4. Here is a 4. Do I need to put my first spot at A?
The X is go like this.
The x-axis is the sideways axis, but an x equals graph needs to be an up and down graph, which is I hear you, it's a little bit kind of funky, but that's just kind of how it goes. I'll explain it in just a second. Let's pick our first point here. We've got A or B. Where does our first dot need to go for the y equals 4? It needs to go at A, right? B, we're not going there. We don't like to start on the x-axis. No good. And right, we need to be a horizontal graph, which goes side to side. Now, I just had a very reasonable connection, right? You said, well, this is the y-axis, and the y-axis goes up and down. So why does our graph go side to side if it says y equals? Basically, this says y equals 4. And if you had to point on the graph all the places where y equals 4, this is where they would go, right? Right here, this coordinate is 5, 4. And what does the y equal? 4. And this coordinate right here is negative 4, 4. And what does the y equal? 4, right? This is the place where the y value is every single time 4. Y is 4, 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 for this whole line. It has to be side to side. That's why it works like that. Now, when we have our graph set up like this, what would the m of a flat graph be?
0.
Nice job. Make sure you don't take too long. We're going through the review. The m is 0. It's a slope. And look, this is a nice flat ground. This looks just like the floor underneath you, which is flat. We'll be right there in just a second. That was basically the only two interesting ones. You got it, Kyle. What is the b value for this graph? It is 4, right? That's where we cross, right there at the 4 number mark. Now, the x graph is even weirder. I hate to say it, the x graph is even weirder. It says -2. Do I put my first dot here at A, or do I put my first dot here at B?
A.
Now, almost every single time we start on the y-axis, but this is the one graph that we need to start on the x-axis. Okay, we are not gonna start at B. We need to start at A because we don't care about the y at all. We only focus on the x. It's a vertical graph. It goes up and down like this. And again, why does it go up and down? This is all the places where the x is -2. -2, 1, -2, 3, -2, 4, -2, 6, -2, -4. It's all right here where the x is -2. Now, what is the m for a vertical graph? Kyle, you did just say it. Undefined. A straight up and down graph is undefined. Some teachers like to talk about this like a cliff, like you could fall off a cliff with undefined slope.
Wait, so what's the other one?
Basically, your slope is either going to be 0, undefined, or just a normal slope, like a positive number or a negative number. There's no other like funky ones. So where does this graph have a y-intercept? Where does it touch the y-axis? It does not, right? They never ever cross. We're going with none for the b value. You can't put 0 because it does not cross at 0. You just got to stick with none. All right, we got 2 more questions down here. These are definitely kind of more interesting, maybe a little bit more difficult than the first 2. I really, really recommend that you work with me on these 2. The first thing is that these are inequalities again. And graphing inequalities has kind of 2 additions to it, all right? Graphing inequalities has, you either need to color above or below, and the line either needs to be dashed or solid, all right? And so normally we make a little bit of a box here, and we put those different inequalities in the box. So above should be the greater than symbols, and below should be the less than symbols. And then solid has the equal sign. So we put the equal signs on the solids. It was a little messy. Not too bad. We also want to kind of remember the, let me set this pass real quick. We also want to remember about dividing by negatives when it comes to inequalities, but it's not as popular to make a question that hard. Now, the second issue that we have for this question is that the y is not by itself. We need to get that y by itself, and so we're going to need to do a -6 on both sides. And when you do a -6 on both sides, they're not going to combine together with the 1/2. It's going to be totally separate. -1/2 x minus 6. And so let's get our m. -1/2, -6. At this point, we've done this before. We're now just going to be plotting our point, starting at -6, which is down here. We're going to do rise over run. Rise 1. Are we going left or right?
Yeah.
We're going left. Nice job. Left 2. Rise 1, left 2. Rise 1, left 2. And pause for just a second before you write down the line. We have a greater than or equal to. Is that solid or dashed? That is a solid line. Okay, so that gives me the confidence to make a nice solid line. And then we have to color it. Are we coloring above or below? This is an above graph, right? I can see right here, right? This is my symbol that I'm working with. Oh, nope. This is my symbol that I'm working with. I drew my box differently last period. Sorry, not that one. We're working with this one. And so this one is the above solid. What a silly little goof. My bad. Now, if we need to shade above, would you say that's on side A or side B for this question? Think about it like a roof. Which side is above the roof? I agree. Side B. Side B is above the roof. Doesn't have to be a perfect coloring. Just do some squiggles. Try to cover up the whole thing. You know, give you 3 seconds to do as well as you can do. All right, we're going to keep going, and we are almost done, everybody. The back is short, different kind of funky questions here. Same issue that I had before. This piece needs to move. It's in the wrong place, so I'm going to do -2x on both sides. I'm going to go ahead and put my M and my B. I'm going to start off with my B and plot my B at the 5. That's pretty easy. Then I want to do rise over run. And if I do my rise 2, how do I know how much to run?
You gotta add a 1, I believe.
Perfect, right? We got to divide by 1. That 1 tells us how much we need to go to the side. and it's a negative, so we're going left. 1, 2, up. 1 to the left. 1, 2, up. 1 to the left. And here we're running out of room.
So you gotta go down.
So you gotta do the complete opposite. Instead of going up left, you gotta go down and right. So instead of going up left, I'm gonna go down 1, 2, and right 1. Always make sure that you're in a straight line, especially when you have to do these opposite world, switch it up backwards kind of things. Make sure you're in a straight line before you draw. Now hold up just a second if you rushed ahead. We have a less than symbol.
We got a dash line.
And that less than symbol, I promise I'm gonna highlight the correct box. This is our less than symbol, which is a below dash, right? So we need to dash it and we need to go below. So the dashed marks is just these nice little, leave the gaps in there. And then the below is the below on side A or B.
B.
And
Think of it like a roof. I think it would be on side A. Nice job. Okay, that's our graphing. We did our inequalities. We did a dashed line. Let's move on. We're almost done. We got 6 questions. And to be honest, guys, these are the last 6 that we might ever do together in our whole life. Here we go. I remember during the kind of practice, a student asked a very good question here. Is the following graph a function? If not, draw a vertical line where the graph fails. So when it comes to functions, anything that looks like it doesn't overlap itself is going to be good. Okay? But as soon as you get a graph that goes back on itself, this is going to be bad. Okay? And the way that we've done this is working with the vertical line test. So for the bad graph, you can see how we're touching twice. 1, 2. So this is bad, bad, bad. But if you look at the good graph, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. It's just one time the whole way. So for our graph, it's very weird looking. How's it going? Good, 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 good. We have a big problem right here. We got an issue. If we have a vertical line right here, we are touching at 2 places, and that is a problem. And so this should be no function. We don't have any passes right now. Gotta wait for somebody to come back. Let's keep it going. We're kind of running out of time today. Let's keep it going. We got the m equals fraction, parentheses minus parentheses. We got a nice job. I heard that the y's go on top, and that's the big secret to this. I hope it's not a secret. I've only said it 675 times. So we need to put those numbers on top of each other, and the y is the top number. So the 4 is the top number with the -3 on bottom. What goes on top? Is it the 1 or the -7? The -7. Because the second number, the y number, is the top number. And the first one, which is the x, is the bottom number. Go to Desmos, type it in. When you type it in, make sure that you just press fraction first. Fraction, parentheses minus parentheses, parentheses minus parentheses, get it in there. 4, -3, -7, 1. Desmos is gonna do it for you. And we get a weird answer, but you know what? I trust Desmos. I typed it in correctly. It looks good. -11 divided by 4. M equals -11 divided by 4. All right, we got 4 questions left. Let's look at this left one. It says write an equation that goes through the following things. So we're going to need an equation that's going to go right here. And we're going to need the m and the b to figure out that equation.
Okay, I got 3 over 4.
It should be 4
Negative.
minus 7. Because that minus comes from the equation and that minus comes from the number. Okay, this m equals 3. What's the b number? Is the b number a 4 or a 1? Secret, neither one, right? This 4 is an x number. This 1 is a y number. We're getting a little distracted. Let's put it away, please, Amir. We got y equals mx plus b. And we need to plug these 3 numbers into 3 of these letters. So, which number comes first in the y position? 1. In the m position is 3. In the x position, we normally use parentheses, is a 4 plus b. We talked about how a lot of students forget to write the plus b, so don't forget that. 3 times 4 makes 12. 1 equals 12 plus b. And then just move that 12 to the other side. Minus 12, minus 12. What's 1 minus 12? Negative 11 equals b. And so what should our equation be? Y equals 3x minus 11. Simple as that. Y equals mx plus b. All right. We have a table here. This table talks about parallel and perpendicular lines. A little bit of vocab that you definitely are going to use in part B and especially going to use in geometry. Parallel lines look like that, and parallel lines have same slopes. So if this is the original slope of 3, the parallel slope, 3. It's the same exact thing. If the original slope is 3 over 4, what's the parallel slope? 3 over 4, right? Super easy. And even if the parallel slope is negative 1, what's the original slope? Negative 1. Amir, you're having a little bit too much fun for the review, my dog. Relax for me. Now, the perpendicular lines make that nice cross. They look like the ceiling tiles. They look like the floor tiles. They look like the coordinate plane on the wall over there. So we need the opposite and the reciprocal. This is a 2-step process. It's like a double flip. So the first opposite means if this one's positive, this one needs to be negative. So if this one's positive, this one needs to be negative. If this one's negative, this one needs to be positive. That's not very hard. That's a very easy step. The other step, reciprocal, means upside down. So if we're working with 3 over 4, the perpendicular slope would be 4 over 3. That is also not very hard. You just have to put the fraction upside down. But it's a little bit weirder. How do we flip a plain old 3 upside down? Nice. We want to think about it like 3 over 1, and then we want to flip that, which is 1 over 3. Same with the negative 1. It's like a negative 1 over 1. We flip that upside down, and it makes positive 1 over 1. And what's the easiest way to write positive 1 over 1?
1.
Just a plain old 1, right? We don't need any of that other nonsense. All right, we're almost done. There's literally like so close to the end. Going backwards, what was the original slope? If not quite, it should be 2 over 5. And 2 over 5. No negative. Because if this one's negative, these ones need to be positive.
Oh, that has to be the opposite.
Right. Always have to be the opposite. All right, we got 2 questions left. Literally, that's it for the entire semester. 2 questions. This one says standard form. Standard form looks like this. AX plus BY equals C. And there's 3 check boxes that we have to have.
No fractions.
No fractions. Nice job. The order has to be perfect.
And then a positive X.
And the X has to be positive. So let's make a positive. Let's make a checklist. The first one. Do we have any fractions?
No.
No.
No. So we're good. We got no fractions. We're almost done, girls. Please don't be distracted. So we got no fractions. Check. Issue number 2, the order. Are we in the perfect order or are we out of? Right, we're out of order. What needs to move?
The X.
We need to move this X. Minus 2X, minus 2X.
Okay, so
Welcome back. Please be quiet, please. Minus the 2X. Negative 2X minus 4Y equals 1. I just put the X in the first position.
and then we have to change it to the X is positive.
And then we need to fix the order, fix the
This
X.
changes everything, right?
Right. Full change. Positive 2X plus 4Y equals negative 1.
Nice.
Now we're looking pretty good. All right. Renai, please sit down. Welcome back to class. Phones away. We've only got 1 question left. We just fixed this standard form question. No fractions, no order, no positive. 2 over 5, 2 over 5, because we got to do the opposite reciprocal. All right, last question here. Solve the following literal equation for the letter D. So, you got to get this D isolated, which means you got to move some stuff. You got to move the 2 and you got to move the 3. Which one do you move first, the 2 or the 3? It's got to move the 2. Is that a positive 2 or a negative 2? This is a positive, so we got to do minus 2, minus 2. All right? That means we have negative 3D equals C minus 2. And I know that this side is going to be messy, but that's okay. We don't care about that side. We just need the D by itself. How do you solve for this? Letter D, you divide by negative 3, divide by negative 3. And so if we write the whole thing,
D equals C minus 2 over negative 3.
C minus 2 over negative 3. And even though that whole side looks crazy, who cares? The D is all by itself. All right, that's the whole piece of paper.